3 seconds at midcourt. Jenkins gives it to Jenkins for the championship.
Happy March Madness pre-calc, and instead of watching basketball for this video, you get to watch 8 to 10 minutes of me do a proof. So that should be exciting. All right, so of course that was Villanova's championship win from a couple of years ago. I think it was 2016, I'm pretty sure, was that three-pointer at the buzzer. But very exciting time of year for all of us. Of course, my Vanderbilt Commodores did not make the tournament this year, but, there's always next year. All right, so anyway, when doing a proof, you're always presented with some true statement, and you've got to show why it's true. All right, so the general idea here is we've been simplifying problems the last couple days, and that's really all the work you've got to show for this. Okay, you've got to work with one side of the equation, and the way I write the proofs for you, you will really generally want to work with the left-hand side. All right, so you're essentially told that this fraction, cotangent theta minus tangent theta over sine theta cos theta, that does equal cosecant squared theta minus secant squared theta. All right, you've just got to show that if we simplify this, if we change the way this is written, if we do one of several different tricks that you'll learn in class, that this, we can change the form of this to look exactly like this. All right, so you're not going to be writing really any equal signs in this whole process. All right, you're just going to do, as you've done in class the last couple days, just showing step by step in a vertical format, working with this expression to make it into this one. So proofs are a little bit easier than just straight up simplifying problems in a way because you're told what the answer is. All right, you just got to show the work. So you'll notice I'm not going to be writing any equal signs. Keep that in mind. All right, you're not solving an equation here. All right, so cotangent minus tangent over sine cosine. All right, there's a few ways out of this, but because there's nothing squared, we can't really use any kind of an identity here. So I would probably just start by writing cosine theta over sine theta, replacing cotangent with that, minus sine over cos to replace the tangent, and keeping that all over sine cos. All right, so that's probably everyone's first step. I'll even number these steps. Okay, you don't have to do this, but I'm going to number the steps just so it's not so jumbled, so you know which step kind of starts or ends where. From here, there'll be a couple of different ways out, all right? So just listen to me for a second. So you could multiply top and bottom of this entire fraction by an expression to get rid of these little fractions, those little denominators. That's one way out, all right? I'll show you how to do that. Alternatively, you could ignore the bottom of this and just get a common denominator on the top, and then do the subtraction to make the top into one fraction. So this is all now one fraction after you get a common denominator and stuff. And then it's sort of a keep, change, flip situation. You'll be dividing one fraction by sine cos over 1, so you can keep the numerator the same and multiply it by the reciprocal of the denominator. That's probably a more common way out. All right, so those are really the two main ways out of this. All right, there are other tricks we'll learn in class, but just working with fractions is an important skill. All right, so the first way we'll do this, and maybe it's the only way we'll do it in this video actually, is to get a common denominator in just the numerator. All right, so I'm going to multiply. Can I use green? Will you see that? Sort of. I'll use the black marker for every step. All right, so if we multiply this fraction by cosine over cosine, and the other fraction by sine over sine, we'll have a common denominator of cosine sine on the top and on the bottom. All right, and because it's written like sine cosine here, I'll write it as sine cosine. So we'll have cosine squared, right? Cosine times cosine is cosine squared over cosine times sine, or sine times cosine, minus sine squared over sine cos, all over sine cos. You do want to show every step in this process, all right? So that's the second step. Now we have a common denominator on top, so I'm just going to combine the two fractions into one. So we have cos squared minus sine squared over sine cos over another sine cos, right? So it's like that fraction over sine cos, or if you want, you can write it as sine cos over 1. So this is the third step. And now we're at that keep, change, flip point, right, where you have one fraction over another. So in step 4 here, run out of room? No. Step 4 would be to keep the numerator, so cos squared minus sine squared over sine cos times the reciprocal of this, which would be 1 over sine cos. All right, and what we end up with is, well, cos squared minus sine squared times 1 is just itself, cos squared minus sine squared, over sine cos is sine squared cos squared. Okay, so that's the fifth step. Now we might seem a little stuck, okay? So I want to make sure you guys understand one thing. So when you're doing a proof, sometimes in the first few steps, you might not see a way out. You might just start rewriting things and simplifying as best you can. And then at a certain point, if you seem stuck, then just go back to the original problem and see maybe what you're trying to prove, and that might help you know what to do next. So we're trying to prove that this side equals cosecant squared minus secant squared. So somehow from this, we've got to make that happen. All right? Now, because these are two separate terms, that leads me to believe that the previous step probably was 1 over sine squared minus 1 over cos squared. All right? So if you're trying to prove something with the reciprocals, the previous step probably was those reciprocals. So 1 over sine squared minus 1 over cos squared. So we probably want to have two separate terms, not just one fraction, but two separate expressions, all right? So that's why, at this point, I would probably split this up into two separate fractions. We have just one term in the bottom, just one ugly factor of the bottom, and we have two factors on top. So we can split this up as cos squared over sine squared cos squared minus sine squared over sine squared cos squared. Now there are other things you might have tried, all right? Like you might have replaced cos squared with 1 minus sine squared, for instance, and you get 1 minus 2 sine squared on top. That wouldn't get you anywhere, all right? But that is something you might have tried. So it's a good idea that once you kind of like clean up some of the fraction work here, like once we're here in step 5, before you just start doing, you keep doing things blindly, at this point you really want to check and see what you're trying to prove, all right? Because you're trying to prove two separate terms, you've really got to split this up into two separate expressions and simplify them both separately so you end up with that kind of form, all right? Cosine squareds here will cancel out, right? The sine squareds here will cancel out. And what are we going to have? We're going to have 1 over sine squared in the next step minus 1 over cos squared. And that's exactly where we needed to get to, right? This is step 7. And then step 8, do I still have, yeah, I'm still on the board. Step 8 is what you're trying to prove. So your last step in every proof you do, I should have said this earlier, I'll say it now, the last step is the right-hand side of the proof, of the identity, all right? So this equals this, you're trying to show this as your last step, exactly how it's written. So this is not quite enough. You should show, okay, a formal mathematical proof, you should show exactly what you're trying to prove, and then if you really want to be formal about it, you would then write QED, which is Latin for quod erat demonstratum, which means, well, I don't know exactly the verb conjugations on this, but it probably means something along the lines of, we have shown what we were asked to show. We have demonstrated that which we were asked to demonstrate. All right, so this is something that you'll see me write on every answer key. After I've shown a proof, I'll write QED, and I encourage you to do the same. All right, but before you write QED at the very end, you've got to show what you've been asked to show, and then you say that in a dead language. Okay, but I hope this was interesting and helpful, and this is kind of what I expect from you guys when you're doing proofs on your own. All right, showing every step clearly, and then your last step being what you were asked to prove, and then drop that QED at the end. All right? Have a good day. We'll do a lot more of this in class.